In the end, the slow-looking circle is doing serious mechanical work. That is why the chapter on the rotor matters to the whole story. Blade aerodynamics. A turbine blade is closer to an aircraft wing than a simple paddle. Blade aerodynamics begins with lift-driven rotation instead of brute force pushing. A wind turbine can look simple from far away. 3 blades, a tall tower, and a slow-turning shape against the sky. Up close, it is a negotiation among weather, structure, software, electricity, maintenance, and the grid. The machine does not command the wind. It accepts the useful part of it and survives the rest. The engineering is made from airfoil profiles, angle of attack, twist, chord length, stall behavior, drag, tip vortices, and root strength. Each piece has to match the others. A wide rotor needs the right tower. A wide rotor needs a tower that can take bending. A generator needs electronics that can shape its output. A control system needs sensors that tell the truth quickly. When the system works, the blades seem calm, but that calm comes from many limits being respected at once. You can see the idea in a blade changing shape from thick root to slender tip, because each section sees the wind differently. The visible movement may take less than a minute, but it carries the work of planners, engineers, technicians, meteorologists, grid operators, environmental reviewers, and local crews. They ask how the wind behaves, how the machine should respond, how power will leave the site, what parts will wear first, and what happens when the weather changes fast. The risk is that bad airflow costs energy and can shake the whole machine. That risk does not make wind power reckless. It makes it disciplined. Good wind engineering turns uncertainty into procedure, measured air, controlled blades, protected equipment, monitored vibration, planned maintenance, and electrical systems that know how to disconnect when they must. In the end, the blade is a long, quiet argument with the air. That is why the chapter on blade aerodynamics matters to the whole story. Pitch control. Modern turbines change blade angle to control power and protect themselves. Pitch control begins with active control at the edge of a changing sky. A wind turbine